For several years now, the biofuels that power cars, jet airplanes, ships, and big trucks have come primarily from corn and other mass produced farm crops. Researchers at USC, though, have looked to the ocean for what could be an even better biofuel crop, seaweed. Scientists at the USC Wrigley Institute for Environmental Studies on Santa Catalina Island, working with private industry, report that a new aquaculture technique on the California coast dramatically increases kelp growth, yielding 4 times more biomass than natural processes. The technique employs a contraption called the kelp elevator that optimizes growth for the bronze-colored floating algae by raising and lowering it to different depths. The team's newly published findings suggest it may be possible to use the open ocean to grow kelp crops for low-carbon biofuel, similar to how land is used to harvest fuel feedstocks such as corn and sugarcane, and with potentially fewer adverse environmental impacts. The National Research Council has indicated that generating biofuels from feedstocks like corn and soybeans can increase water pollution. Farmers use pesticides and fertilizers on the crops that can end up polluting streams, rivers, and lakes. Despite those well-evidenced drawbacks, 7% of the US's transportation fuel still comes from major food crops, and nearly all of it is corn-based ethanol. The study was published in the journal Renewable and Sustainable Energy Reviews. Though not without obstacles, kelp shows serious promise as biofuel crop. Government and industry see promise in a new generation of climate-friendly biofuels to reduce net carbon dioxide emissions and dependence on foreign oil. New biofuels could either supplement or replace gasoline, diesel, jet fuel, and natural gas. If it lives up to its potential, kelp is a more attractive option than the usual biofuel crops, corn, canola, soybeans, and switchgrass, for 2 very important reasons. For one, ocean crops do not compete for freshwater, agricultural land, or artificial fertilizers. And secondly, ocean farming does not threaten important habitats when marginal land is brought into cultivation. The scientists focus on giant kelp, Macrocystis pyrifera, the seaweed that forms majestic underwater forests along the California coast and elsewhere and washes onto beaches in dense mats. Kelp is one of nature's fastest growing plants and its life cycle is well understood, making it amenable to cultivation. But farming kelp requires overcoming a few obstacles. To thrive, kelp has to be anchored to a substrate and only grows in sun-soaked waters to about 60 feet deep. But in open oceans, the sunlit surface layer lacks nutrients available in deeper water. To maximize growth in this ecosystem, the scientists had to figure out how to give kelp a foothold to hang on to, lots of sunlight, and access to abundant nutrients. And they had to see if kelp could survive deeper below the surface. So Marine Bioenergy invented the concept of depth cycling the kelp. The USC Wrigley scientists conducted the biological and oceanographic trial. The kelp elevator consists of fiberglass tubes and stainless steel cables that support the kelp in the open ocean. The juvenile kelp is affixed to a horizontal beam and the entire structure is raised and lowered in the water column using an automated winch. Beginning in the year 2019, research divers collected kelp from the wild, affixed it to the kelp elevator, and then deployed it off the northwest shore of Catalina Island near Wrigley's Marine Field Station. Every day for about 100 days, the elevator would raise the kelp to near the surface during the day so it could soak up sunlight, then lower it to about 260 feet at night so it could absorb nitrate and phosphate in the deeper water. Meanwhile, the researchers continually checked water conditions and temperature while comparing their kelp to control groups raised in natural conditions. The researchers found that depth cycled kelp grew much faster than the control group of kelp, producing 4 times the biomass production. Prior to the experiment, it was unclear whether kelp could effectively absorb the nutrients in the deep, cold and dark environment. Nitrate is a big limiting factor for plants and algae, but the study suggests that the kelp found all it needed to thrive when lowered into deep water at night. Equally important, the kelp was able to withstand the greater underwater pressure. The farm system can be assembled from off-the-shelf products without new technology. Once implemented, depth cycling farms could lead to a new way to produce affordable carbon neutral fuel year round.